Differences between VAR and ARIMA. VAR versus ARIMA. VAR or vector autoregressive models are used to model the dynamic interrelationships among multiple time series variables. Here, each variable is regressed on its own lagged values as well as lagged values of other variables in the system. VAR models do not consider long-term equilibrium relationships among variables, whereas ARIMA or autoregressive integrated moving average is a statistical analysis model that uses time series data to either better understand the data set or to predict future trends. The purpose of VAR model is to capture the relationship between multiple quantities as they change over time, whereas the purpose of ARIMA model is to predict future securities or financial market moves by examining the differences between values in the series instead of through actual values. VAR models are widely used in time series research to examine the dynamic relationships that exist between variables that interact with one another, whereas ARIMA model is used to understand past data or predict future data in a series. It's used when a metric is recorded in regular intervals, from fractions of a second to daily, weekly or monthly periods. ARIMA is a type of model known as a Box-Jenkins method. VAR models are of three types such as structural, reduced form, and recursive, whereas there are two types of ARIMA models such as seasonal and non-seasonal. VAR model helps in time series research by allowing one to inspect the dynamic relationships between the variable interacting with each other, whereas ARIMA helps to accurately forecast short-term movements in stock prices and stock returns, demonstrating its efficacy as a predictive model. VAR models are important because it's widely used in time series research to examine the dynamic relationships that exist between variables that interact with one another. In addition, they are also important forecasting tools that are used by most macroeconomic or policy-making institutions. Whereas ARIMA models are important because these models can easily transform non-stationary data into stationary data, a necessary step for effective forecasting. VAR models are suitable for short-term dynamics, whereas ARIMA models are suitable for non-seasonal series of numbers that exhibits patterns and is not a series of random events. For example, sales data from a clothing store would be a time series because it was collected over a period of time. VAR models are bidirectional. This means that, in this case, a dependent variable is impacted by its previous value, any other variable's value, or both. Whereas ARIMA models are unidirectional. This means that dependent variables are impacted by lag or past values themselves. There are three assumptions of VAR models such as the error term's conditional mean is zero, the possibility of large outliers is low and variables within such a model are stationary. Whereas, there are two assumptions of ARIMA models such as stationary and invertibility. Stationarity means that model assumes that the time series is stationary, implying a constant mean, variance autocorrelation over time. If it is not, differencing is applied to achieve stationarity, and invertibility is another assumption, implying that the model's error terms can be expressed as a linear combination of current and past forecast errors. In short, VAR or vector autoregressive model refers to a type of stochastic model that relates a variable's current observations with the past observations of itself and other variables within the system. It captures the interdependencies and evolution between different time series. Model is used in econometric and finance as it offers a framework for fulfilling crucial modeling objectives, including forecasting, structural inference, policy analysis, and data description. Whereas ARIMA model uses statistical analyses in combination with accurately collected historical data points to predict future trends and business needs. ARIMA models predict future values based on past values. ARIMA makes use of lagged moving averages to smooth time series data. They are widely used in technical analysis to forecast future security prices. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.